Today we will experiment in Python about how to add multiple sine tones to create many different type of signals what we encounter in signal processing or in real world. So let's start. So I'm going to explain how we can generate a rectangular wave, a triangular wave, and one impulse train using a sine tone. So, as discussed in previous lectures and videos, we are using Python. So, this is a piece of code written in Python in an IDE called Spider, and I'm generating a sine tone here with a sampling rate of 1000 kilohertz, and sine tone is of 0.2 kilohertz, means 200 hertz, and it's sampled at a rate 1000 kilohertz. So clearly a case of oversampling because we required only twice minimum. But this is to show you the clarity. Now we generate the time ticks here on line number 42. And this is a single sine wave. So if you see the plot, this is a single sine wave. With this title, simple sine wave. If you see its period is 5000 ticks. So that you can figure out using this sampling rate why it is 5000 ticks. That you can answer me in the comment box, which I explained in previous video. Now I can generate a rectangular wave using this one. So how is that possible? So if you see, we know the concept that if you add a sine tone, its odd harmonics, you'll get a rectangular wave. So see what I'm doing here. In line 56 to 58, what I'm doing is I'm adding a sine tone, okay, with a frequency 0.2 kilohertz and taking its odd harmonic. So here sum is equal to sum plus 1 by I into sine of 2 pi fct into I. So this I term here will give you that odd harmonics because this loop is running in the range of 1 to 1000, 10,000 and with a increment of 2. So it will increment 1, 3, 5. So if I keep on adding this and sum that odd harmonics of sine tone, then it will give you a rectangular wave. So if you see this sum is what I'm plotting here, and this is with the title square wave. If you see here, this has become a square wave, kind of a square wave. If you add more numbers, like not up to 10,000, if you add to infinity, it will become a proper square wave or rectangular wave, whatever you want to say. But notice one thing. The period of the sine tone is also 5000 ticks, and period of this rectangular wave is also 5000 ticks. You see, period is from one full cycle, so it's up to 5000 here. Where it's crossing 0, this is 5000. Same way, if you want to generate a triangular wave, you have to add all harmonics of sine tones. Harmonics are basically multiples of your original base frequency. So if I'm running the loop in range 1 to 10,000, but with the increment of 1, like 1, 2, 3, not skipping the even harmonics, even I'm taking all the harmonics. Then this time this sum is this what I'm plotting, and it's a triangular wave. If you see here, it's a triangular wave. Again, if you see, one period of this is 5000 from 0 to 5000. And same way, we can generate the direct delta function also. So we can do, or we can generate any kind of tones or any